Hello again. All right, we have a very basic idea of what a decision tree is and how data moves through it, but how on earth does it learn how to make predictions? This process, known as training, is crucial in all machine learning tasks. Let's unpack how a decision tree is trained. So the training process for a decision tree is also known as growing the tree for obvious reasons. We start from the node and head through the branches, through the decision nodes and end at the leaf node. And it's done in a similar fashion to the prediction process or the decision process that we use a completed trained tree for. In other words, we start at the root node for training and we slowly make our way and create each of these decision nodes and finally end up at the terminal nodes. So as usual, we have a finite number of rows or observations in our training data set, and that is known by the letter N, big N. Let's say for example's sake that we have 100 rows in our data set. Now, when we grow our decision tree, what happens is at the root node, all of these 100 observations are available to us. And immediately, because that first root node is actually a decision node, we make a decision and we say, for a particular feature or predictor variable in our data set, all of the values that are smaller than perhaps the value D go to the left, and all of those that are greater than the value D go to the right. So let's take an example and say that 30 of these 100 rows satisfied the left fork of this decision node, and the remaining 70 went this way. Now that means that at this decision node, we don't have all 100 observations to use for the next decision. We only have these 30 over here. So let's say again that at this decision node, the way that we queried the variables, or the way that the decision tree queried the variables, meant that only 10 observations went this way and 20 observations went that way. So it's clear that as we go down this tree, we decrease the number of observations that we have available to us at each point, splitting them into smaller and smaller subsets. The question is now, how are those decisions actually made? What leads to a particular variable value at each of these decision nodes that splits the data into these subsets, and how big are those subsets, and what does it mean? So the answer to that is at each decision node that we've drawn here, so at each split into smaller and smaller subsets, we carry out what we call partitioning, which is a result of asking and answering two questions of our data. The first question is, which predictor variable are we going to split on? And when we say predictor variable, we of course mean the features in our data set. So those are the X values. So it's going to be X1 or X2 or X3 and so on. Of course, those are just stand-in variable names. And typically we would measure things like income or education and that sort of thing. And the second question is, once we know which predictor variable we're going to use, what value of that variable, this one over here, do we use to split? So these are both questions. And that question fortunately has an answer. The answer is a technique known as recursive binary splitting. So it consists of three sort of primary major macro steps that we can look at individually. The first step is to say, at the decision node in question, it is the duty of the algorithm to consider all possible binary splits. What does that mean? Well, binary means two. So the binary splits that are being considered are all of those that split the 100 rows in our data set into two smaller subsets of those 100 rows. Binary splits are handled slightly differently depending on what type of variable we are looking at. So if it's a continuous variable, i.e. a numeric variable that measures something like age or income or something like that, splitting is done according to perhaps variable x1 is this continuous variable. Is it smaller than a value d? Or is it greater than or equal to this value d? So that's an obvious one. Is income less than 100,000, or is it greater than or equal to 100,000? But for discrete values, also known as categorical data, we might have something that measures the education level of a group of people, and it's split into postgrad or high school or undergrad, that sort of thing. Of course, we don't have a sliding scale of values that we can split at. So in that case, the way that we would split a variable x2, which is a discrete variable, we would say, is x2 equal to class D, i.e. is that person an undergrad, or is that person not in that same class D? So it's all the people who are undergrads and all the people who are not undergrad. It's not like we have a split available for every group within that variable. It's only 2 splits in each case. And in the case of a discrete variable, it's in the class or not in the class. Right, step 2 says that once we've considered all these possible binary splits and we've determined whether it's a continuous or a discrete variable, the algorithm is going to select the split based on minimizing the mean squared error of the resulting subsets. So that's a bit of a mouthful. So let's break it down a little bit and try and understand it. Keep in mind, let's always head back to our visualization of this decision tree. We started with the 100 rows and we split that into something like 30 and 70. So let's leave it there for now. And what step 2 means, select split based on minimizing the MAC or the mean squared error of the resulting subsets, is it means for all 30 rows in this particular subset in the left of this particular decision node, which is another way of saying for all variables x1 that were smaller than d. So for instance, on the left, these were all the ones that were smaller than d, and these were all the ones that were greater than or equal to d. So for all of those that were x1 smaller than d, we calculate the MSE. Remember, the mean squared error is the squared error of each of those particular observations. So during the training process, we look at all the y values. We determine how far that y value is from the mean y value in that group of 30 observations. We square each of those, and then we take the average of them. That's the mean squared error. So we calculate the mean squared error of those 30. Once we've done that, we calculate the mean squared error of these 70. And if the sum of those mean squared errors is minimized, i.e. it's the best mean squared error or the lowest mean squared error of all of these different binary splits that we considered up here, then that is the split that we keep. Right, so steps 1 and 2 take us from around over here to calculating the lowest MAC over here. So it gets us through one decision point, which means that step 3 must take us through the rest of the tree. And step 3 says for each resulting subset, where the subset is this 30 or this 70 or whatever those get split into in each case, we repeat the above steps 1 and 2 until some stopping criteria is reached. The stopping criteria means that we no longer want to grow the tree anymore, according to some rule that we have either arbitrarily or meaningfully set out at the beginning of the model design process. A couple of examples of stopping criteria might be that we have a minimum number of observations available to us. So what does that mean? Well, 100 got split into 30, and maybe 30 got split into 10 and 20, and that 10 got split into, say, 5 and 5, and that 5 got split into 2 and 3. At some stage, we are going to have too few observations to be able to make a meaningful split. So that is a stopping criteria of setting a minimum number of observations in each of the subsets. Another example of a stopping criteria might be the marginal improvement in the mean squared error of the last subset. So if we start getting improvements in the mean squared error in each subset that are so minuscule that it doesn't really make sense to continue training the model, then we would also stop it. So that's the training process, but does that always lead to an efficient model? And if not, how can we look to improve the generalizability of that model? The answer to this question is to use a process known as pruning, a concept we'll cover in the next video. All the best, and we'll see you right away.